Hello students. So here are my suggested solution for exercise 6C. I hope you are ready. Let's go. Okay. So what we're supposed to do over here, right? So in this particular exercise, we are supposed to rearrange the formula um, based on what the question requires us to make the subject, right? So in this case, we want to make A the subject from this formula, R equals to M times A plus G. Okay. So how do we do that? Well, the first thing we're going to do over here is that we are going to bring this M on the right side to the left. Okay, because we're going to divide by both sides with M. Okay, because we want to isolate A. So this M over here, well, I don't want it to multiply it to get M times A. That's not what we want. We want A to be on its own, to be isolated. That's what it means by making A the subject. So I can just divide both sides by M, and so we have so we have R over M equals A plus G, right? Of course, left hand side equals right hand side equals left hand side. We can always switch them around. So I write it in this manner because I want my A on the left hand side. It's cleaner and neater for me, right? So once we do that, then we just need to subtract G on both sides. So minus G on the left, minus G on the right. We have just A equals to R over M minus G. Pretty straightforward question if you ask me, right? So the next one, 2D. This time round, well, those of you who remember the lesson from mensuration will recognize that this is the area of a trapezium, the formula. This time around, we want to make B the subject. So how do we go about doing it? First thing I'm going to do is, the fractions is tends to confuse people. So why not just multiply by 2 on both sides to get 2A equals to A plus B times H, right? Since I want to keep my B isolated, so I'm not going to multiply the H in, I just divide the H on both sides, right? So we have 2A over H equals A plus B. We can flip them around. And finally, to leave the B on its own on the left side, we just minus A on both sides. So minus A on left hand side, minus A on right hand side. Final solution, B equals to 2A over H minus A. Okay. Next question, we have question 6b. A equals to 2 pi r square plus pi r L. So of course, this is another popular formula from your mensuration question, right? This is actually the surface area of the curved surface area of the cone pi r L. Then we have 2 pi r square, which is two circles. Interesting. Okay. So these are some of the very familiar formulas, but we don't really need to know what the formulas is needed at this point of time, because all we are interested in right now is to make L the subject, right? So how do we make L the subject in this case? Well, first of all, we see that there's only one copy of L over here with pi r L. So I'm just going to keep this entire term pi r L, right? So pi r L is equals to A minus 2 pi r squared. I just need to minus 2 pi r squared on both sides. Okay, once I have that, I just divide everything by pi r. Job done. Okay, not the most complicated procedure ever, right? So uh, takes a while to be comfortable with this idea, but remember, the idea is whatever unknown we want to be the subject, we need to isolate it, right? So if there's only one copy of it, it's very straightforward. It's more than one copy of it, then some manipulation needs to take place. Okay, here we have another example, 9b. Okay, so this is actually basic, v basically stands for velocity, u is the initial velocity, a is our acceleration, and s is our displacement, right? For those who manage to recognize the formula, but we don't really need to know it at this point of time. It's good that you know it, but not a requirement to get this question correct, because what they want us to do is just make u the subject, right? So once again, I look through and I see that, okay, u square is the only term that has u. So I'm going to isolate it. So u square equals to, well, v square minus 2as, right? I bring the 2as to the other side of the equation. Okay. Now, from u square to get u, I need to square root it. But the thing we need to note is that u can be both positive or negative. So I mean, there's no condition that's laid out in the question that says that u must be positive. So we need to include both the positive and negative. And then after that, the root of the whatever expression we have in the earlier line. So this is the solution. Okay. Well, next one, question 11. What's the situation in question 11? Uh, Question 11 is actually a word problem. Of course, I didn't put it here because you know where the questions come from. Yeah. But let me read it out very quickly. The time taken t for pendulum to complete one oscillation is given by the formula that you see on the screen there, right? And then after that, part one, what they want us to do is to express L in terms of t and g, right? So we're going to do that. So we want L to be the subject. So we want the square root of L over G on its own first, isolate it. So we're going to divide both sides with 2 pi, right? So T over 2 pi. Now, after that, to, to, um, to get rid of the radical sign, right? We just want L over G. What we can do is we square the left hand side and square the right hand side. So left hand side squared, the square root, the symbol can be taken away. And on right side, t squared give us t squared, right? 2 pi square give us 4 pi squared because 2 square is 4. So 2 times 2, 4, pi times pi, pi squared. So this is what we have. And finally, we just need to multiply both sides with g. So that gives us L equals to gt squared over 4 pi squared. So that's the formula that we have with L as the subject. Part 2 of the question goes like this. It says that um, right, they say that we're going to take g as 10 meters per second squared. Actually, g is the gravitational acceleration, right? We know that if you are familiar with the formulas when it comes to pendulum. Okay, so they say hence find the length of the pendulum, which is L, right, represented by L, if it takes 12 seconds to complete 20 oscillation. So this is basically just a question where we are supposed to substitute in the numbers, right? So the first thing we are going to do is we need to see what information we need. In this particular case, we want to find the value of L. And what we need is we need the value for G as well as the value for T. The value for G is given as 10, which we already know from the question. So we need to find out what T is, right? So to find T, I'm just going to take 12 seconds divided by 20 oscillation because T is the time taken for one oscillation. So we have 20 oscillation, 12 seconds. So 12 divided by 20, 0.6 seconds. So that's the value for T. So we substitute it into the formula and we obtain the value 0.0912 meters. That's the length of the pendulum, rounded off to 3 significant figures since they did not specify the um, degree of accuracy. Okay, so that's question 11. Question 15. Question 15 is another word problem. So let me just read it out for you. It says that given that y is equals to 3x plus the cube root of a plus b squared, so you can see that on the first line, they want us to find the value of y when a is 13, b is 15, and x is 3.8. So part A, straightforward. Again, just substitute in the values. A is 3.8, x is 3.8, sorry. A is 13, b is 15. So substitute the value in, work it out carefully with your calculators. You get 17.6, right? In part B, this time round they want us to find the value of A when B is 13, X is 8.5, Y is 3.5. So what we're going to do is we're going to make A the subject, okay? That helps us to straight away get the value when we substitute it. So if you are very comfortable with changing the subject, which I hope all of you eventually acquire the skill, so this is what we can do, right? We're going to just bring the 3x over to the other side, minus 3x on both sides. We get cube root equals to y minus 3x. So over here, to reverse the process of cube root, we just cube the left hand side, cube the right hand side. This is what we get, right? There's no need to expand this. I know some of you may be thinking about expanding this. You will learn how to expand this in a future lesson known as binomial theorem, but we'll leave that for the future, right? Right now, it's good enough to leave it in this form. And then just minus b squared on both sides. So we get a. So we have a equals to y minus 3x cubed minus b squared. Then we substitute the values as given by the question. We realize that A is 688, three significant figures. Okay. But C, this time round, they want us to find the value of B, right? So this time round, let's make B the subject. Why not, right? So to make B the subject, the first step is the same. Okay, we are going to cube both sides. Okay, we know that A plus B squared equals to Y minus 3x cubed. We already have that from the previous section of the question. So after that, to get the b, we just leave the b square here minus both sides with a, right? Subtract both sides with a, so we get this, okay, minus a. And then because b squared, to get b, we actually need to square root it. But since the question did not specify whether b should be positive or negative, we need to include both the positive and negative component. So both positive and negative, square root this entire expression. So now that we have the situation where B is the subject, just sub in the values that's given by the question, and we have B is plus minus 27.5, three significant figures. Or you can write it as B is 27.5 or negative 27.5. It has the same meaning, right? Okay. So the question now asks, is it possible to have the value of y if a plus b squared is less than 0? Well, the answer to that is true, right? It is possible for a for a plus b squared to be a negative number, because it is possible to cube root a negative number. We are unable to cube root a negative, I mean, sorry, we are unable to square root a negative number in this context, because we are not dealing with imaginary numbers. But cube root a negative number is fine, right? It works. It's only square root that we have an issue. Okay, so we'll talk more about negative numbers, of course, in the future. But it's good enough for you to have this understanding that you can actually cube root a negative number. Okay, so and that is the last question that I asked you to attempt, if I'm not mistaken. Yeah, that's correct. So yeah, hope you manage to gain a good understanding of this chapter based on these exercises. Of course, if you feel that you need more practice, please continue to keep practicing, because as with any skills, mathematical skills is also something that you get better when you practice more, right? So hope you have done well. Have a nice day.